Okay, so I gave you several examples in section 7.2 where you were testing claims using Z. And the key thing to remember there is that the Z-test was used anytime the value of sigma, the population standard deviation, was known. So in 7.3, you're going to be looking at the same hypothesis test in terms of the 5 basic steps. However, the difference here will be you're looking at cases where the value of sigma, the population standard deviation, is not known. So what that's saying is you have a standard deviation, but it's only the standard deviation for a sample data set. And when that happens, the only change that will occur in the steps of the hypothesis test is that when you get ready to find your critical values and your rejection region, you will not use Z, the standard normal table. You will use a T distribution instead. Okay, but everything else is going to look the same. So in my previous video, I went through 3 different examples, one for each type of test, just showing you how to use the T distribution table. So if you need to go back and reference that, that was all shown in my previous video for section 7.3. All right, what I want to do here is walk through a complete hypothesis test using T to show you how similar this is to the Z-test that you've been doing in section 7.2. All right, so the first thing I always do when I'm given a claim to test is I figure out my null and my alternative hypothesis. All right, so a fitness magazine advertises, here's their claim, this is what they're saying, that the mean monthly cost of joining a health club is $25. So my claim here is that the mean mu is equal to 25. So if I go ahead and write the opposite of that, the opposite of being equal to 25 is, of course, being not equal to 25. And then now I know the equality always goes to the null, and the inequality always goes to the alternative. So this is no different than what you did for the Z-test. You always set it up the same way. All right, and since our claim is that the mean is equal to 25 for this hypothesis test, our claim is in the null hypothesis. All right, so now right here is a good place to go back and look at the data that you're using in your test, because you want to make sure you're careful about that standard deviation and you know whether to use Z or T. All right, so I'm going to come up here and pull the other information that I have now. So I'm looking at a sample of 18 clubs. Okay, so that's my sample size N. And the mean of the sample, that's X bar, is $26.25. And then here's what's super important, all right? The standard deviation is $3.23, but this is not given as a population standard deviation. It's given as the standard deviation of the sample only. So since this is a case where I do not know the value of sigma, that's how I know this is going to be a t-test, not a z-test. All right, and what that means is when I go to get my critical values and my rejection region in this next step, I'm going to look at the t distribution table rather than z. All right, now, some similarities, you still look at the alternative hypothesis to determine if you have a left, a right, or a two-tailed test. All right, so we have not equal to in the alternative. That means this is a two-tailed test. And that means when I go to my t-table, I'm going to look up a two-tail alpha. And alpha is given here, the level of significance at 0.10. Now, I don't have to divide that by 2 like I did for Z. The t-table works differently. I just specify that it is a two-tail alpha. And my degrees of freedom for the mean are always n sample size minus 1. So I'm looking at 17 degrees of freedom. So I'm going to take this to my t distribution table. All right, I'm looking at a two-tail alpha this time of 0.10 and 17 degrees of freedom. So that's corresponding to a value, a critical value here of 1.740, and then I need to figure out what the sign should be. So there I'm just going to remember, if it's a left-tailed test, I make it negative. If it's a right-tailed test, I keep it positive. And if it's a two-tailed test, I include both. So my critical values here for this two-tailed test are going to be 1.740 from the table and negative 1.740 on the other side. Okay, so I got critical values. I've got my shaded rejection region. All right, the next thing I need to do is I need to calculate my standardized test statistic, just like I did for Z. All right, now I'm going to label this as a value of T because this is a t-test, but the way it is calculated is exactly the same way that you did for Z. All right, so you start with your sample mean, 26.25. You subtract the value of mu, that's what you're testing. All right, so over here we're looking at a value of 25. And you divide by standard deviation, this is S here because we don't know sigma, over the square root of the sample size n. Okay, so I'm going to calculate my value of T here. And if I round this, I'm going to round to 3 decimal places. My test statistic is 1.642. And just like for Z, the way I make my decision is I take that test statistic and I look to see if it's in the shaded or the unshaded region. So 1.642, it's positive, but it is less than 1.740. So it would be somewhere back here to the left of 1.740. Now remember, what's important for your decision, just like for Z, is that it's not in the shaded region. All right, it's in the unshaded region. And when your test statistic is in the unshaded region, you fail to reject the null hypothesis. Now, the interpretation will work the same way that it did with Z as well. All right, so when your test fails, that always means there is not enough evidence And then if we look back at our claim, right, our claim was in the null hypothesis. So we want to remember here is you can only reject claims if they're in the null. You can only support claims if they're in the alternative. So because this claim is in the null hypothesis, there is not enough evidence to reject the claim. Okay, so what I want you to really see here is that it's the same 5 steps. Anytime you want to run a hypothesis test. The only difference is that when you do not know the value of sigma, all right, when you only have a sample standard deviation, you get different critical values. You go to your t-distribution rather than your standard normal, but everything else in the test will be done the exact same way.